Hello everyone. Today I am going to explain the Bohr model of the hydrogen atom. The Bohr model of hydrogen atom consists of a planetary model, and the force applied to the electron is given by Fe equals to 1 by 4 pi epsilon naught E square by R square E vector R, which is denoted by mv square by R, and the V reduces to E by root under 4 pi epsilon naught mr, and the total energy is given by half mv square, that is K plus V. K, that is kinetic energy, V, that is potential energy, is equal to minus E square by 8 pi epsilon naught R, which comes by E square by 8 pi epsilon naught R and minus E square by 4 pi epsilon naught R. The failure of classical planetary atomic model. A neutral atom consists of a nucleus with positive plus q charge and plus q number of electrons, the same number of positive charge and same number of electrons. Assuming the hydrogen atom, the nucleus is attracted by the nucleus. Even in circular motion around the nucleus, the electron loses energy, which is given by Rutherford, which is considered as a failure of planetary atomic model. Classical EM theory: an accelerating charge continuously radiates energy, and thus R decreases and the electron would eventually crash into the nucleus, which is not possible. We can see that every nucleus, every atom is stable, but in this model the electron would eventually crash into the nucleus, which is not possible. Therefore, the classical atomic model, the planetary atomic model, is a failure. Next, we come upon the failure of planetary model, doomed because the electron radiates energy while orbiting around the nucleus. But there is some truth in it, since Rutherford successfully describing the scattering experiment. In 1930, Niels Bohr postulates that electron may be in stable, non-radiating circular orbits called stationary orbits. Niels Bohr's postulate: existence of stationary states of the orbiting electrons, transition between electronic stationary states, that is given by E equals to E1 minus E2, which is h nu. Classical laws of physics does not apply to transitions between stationary states, and electron can only exist in orbit, which its angular momentum is given by L equals to R bar corps P bar, which is under the modulus sign, which is mvr equals to nh by 2 pi, and n is a positive integer, that is 1, 2, and 3. Bohr radius is given by nh by mr. H is the Planck's constant, and since v equals to e by root under 4 pi epsilon naught mr, which is given from the planetary model, we can deduce the diameter of the hydrogen atom in the stationary state, that is Rn equals to 4 pi epsilon naught n square h square by 4 by m e square, that is n square a naught, and a naught is the Bohr radius. Again, I am repeating, Rn is given by 4 pi epsilon naught n square h square by m e square, and it is given by n square a naught, the Bohr radius. Calculation: Rn is given by 4 pi epsilon naught n square h square by m e square. H equals to 6.6 into 10 to the minus 34 joules per second. E naught is 8.85 into 10 to the power minus 12 c square by nm square. M equals to the mass of the electron is 9.1 into 10 to the power minus 31 kilogram. E equals to 1.6 into 10 to the power minus 19 coulomb. And from the calculation we get A naught equals to 0.53 into 10 to the minus 10 meter, that is 0.53 angstrom. And diameter of hydrogen atom at n equals to 1 ground state, it is given by 2r1, that is 2 a naught, approximately 10 into 10 to the power minus 10 meter. It is the lowest energy of the hydrogen atom. Energy levels of hydrogen atom: En is given by minus E square by 8 pi epsilon naught Rn, and E naught is minus 13.6 electron volt. And from that we can calculate the wave number, that is 1 by lambda is equals to EU by EL, matlab energy of nucleus by energy of electron by Hc, that is R infinity is equals to, at R infinity is the Rydberg constant of hydrogen, R infinity into 1 by NL square minus 1 by NU square. And at first the spectra is at first level, that is minus 13.6 electron volt, then it is minus 3.40, then minus 1.51, and thus it increases in energy. The spectral aliveness of hydrogen is given by this figure. You can check it, that n is greater than L and L equals to 1 and n equals to 2, 3, 4, that is Lyman series, L equals to 2, n equals to 3, 4, 5, Balmer series, L equals to 3, n equals to 4, 5, 6, that is the Paschen series. Emission and absorption. While shining and white light, all visible frequencies, one observes a spectrum containing dark lines, that is called absorptions. These lines are the same and observed in the emission spectrum. Hydrogen is in its ground state, called absorption, and then the atom goes back to the ground states by emitting photons, that is called emission. This is the hydrogen absorption emission spectra, and this is the hydrogen absorption spectrum, and this is hydrogen emission spectrum. We can see that hydrogen alpha line is at 656 nanometer, and the transition is from n equals to 3 to n equals to 2. Okay, this is the sun, and the mark, it is given by A B C D E D1 D2 E F G H, from extreme red to extreme violet, that is the visual from this side. And you can see the layers is made by terrestrial oxygen, hydrogen, sodium, solar iron, solar hydrogen, and solar calcium. Quantum to classical mechanics. In the limits of where quantum and theory should agree, the quantum theory must reduce to classical result. The classical result is obtained, and the result of quantum field should be reduced to the classical result. And the limitations of the Bohr model is a limitations are, from the Bohr model we can get the works on only single electron species, that is hydrogen atom, could not account for the intensity of the fine structure of spectral lines, and could not explain the binding of atoms into the molecules. These are the limitations of Bohr's orbital. This is one exercise, you can check it out. The electron in hydrogen atom is n equals to 2, and the state absorbs the photon of wavelength 327 nanometer. Does the hydrogen become ionized? The energy of n equals to 2 state, En, we can calculate using the formula, that is minus 13.6 n square electron volt, and then E2 equals to minus 3.4 electron volt. To ionize, the photon should have an energy higher than 3.4 electron volt. To calculate the energy of photon, we can use E equals to hc by lambda, putting the value of h, c, and lambda, that is 327 nanometer, 327 into 10 to the minus 9. We can get energy of photon is 6.1 into 10 to the minus 19 joule, and 1 electron volt equals to 1.6 into the minus 19 joule. Therefore, the energy of photon is 3.8 electron volt, which is greater than 3.4 electron volt. Therefore, the hydrogen atom will be ionized. And next, there is an exercise for you. The Lyman series is n equals to 1, n equals to 2, n equals to 3. You can calculate the value of lambda. Similarly, for Balmer series, L equals to 2, n equals to 3, 4, 5. For Paschen series, L equals to 3, n equals to 4, 5, 6. You should calculate the value of lambda. Thank you, everyone. That's all.